Okay. Section 3.2. Polynomial functions. Any questions? Go ahead. Ladies, go ahead. Any questions? Okay, so polynomial functions are linear and quadratic, but they were done a long time ago, and one of them today, again. So what we're looking for right now is third, fourth, fifth, and so on and so forth degree. Higher level, higher degree than 1 and 2. So there are basically two categories: odd degree and even degree. I am not talking about odd or even functions. I'm specifically talking about the degree of the polynomial function, which has nothing to do with symmetry of odd and even. Okay, so odd degrees will be, for example, linear or cubic, x cubed plus 1, and so on and so forth. Even degree will be something like f of x equals x squared, or f of x equals x to the fourth plus 2x minus 1, and so on and so forth. Now, there are a lot of similarities, and especially one that I want to talk about. If the degree is odd, all odd degree functions will have something in common with this. All even degree functions of any degree, 4, 4, 6, 8, and so on and so forth, will have something in common with that function. So I'm going to list what we need to present in order to graph such a function. But I will come back to this idea when it comes to one particular item that we have to look at when we graph these functions. Okay. So here's a long list, or longer than what we had before, to graph a polynomial function. Notice that I do not refer to linear and quadratic. Higher degree, degree 3, 4, 5, and so on and so forth. We need to show, not in the particular order I'm going to list them in. Number 1, domain. 2, this is not the exact order. We'll sometimes may have to change it or not. It doesn't matter, really. X-Intercepts. And this has never happened before. Their multiplicities.
Water restored. Water in our no.
So X-intercepts and their multiplicities. X-intercepts and their multiplicities. We have no knowledge of that just yet. Good. Number 3. Y-intercept. Number 4. Degree. 5. Max possible number of turns. 6. Say it again. Nope. It has something to do with it. Absolutely, it has something to do with it. I agree. Maximum possible number of turns and behavior. We have not heard of that before. 7, range. 8, our best friend, symmetry. That means odd or even, but not degree. And the last one, number 9, max min with TI 84, 83. We don't have the information. We cannot do this by hand. Okay, TI 84, a graphing calculator. Okay, so let's start. Let's start with, it's up to you, an odd degree or an even degree? Even, very good, awesome. On page 378, let's start with 47 caught my eye. If you want to choose, you can choose any time. 47, 378. And this is x to the 4th minus 2x cubed plus x squared. Okay. Again, as I mentioned, we will have to show all these, but the order is not important. I strongly recommend, of course, this is the first problem I have to discuss a lot, multiplicities and behavior, etc., etc. So this first problem expected to take 10 minutes. And moving forward, 1.5 minutes. But the first one, I have a lot to say. You know that. Okay, so I will get a table going from the very beginning where I will summarize all the information, because it may take me 3 pages of work. And if I don't summarize it in a table, it will be difficult for me to come up with a graph. Okay, so I will cross them out as we go along. Again, the order is not important. So can anyone give us the domain of this function? Right, polynomial functions are friendly. They will never bother us. It's not a rational function. It's not a radical function. They don't have any difficulties. No, they don't encounter any potential problems. Perfect. So this was done. I would like to continue with the Y-intercept because it's the easiest. Can anyone give us the Y-intercept of this function, or how we determine it? Yes, I have to find f of 0. This is the Y-intercept, and it's 0. Perfect. So that is done. I would like to continue with the degree. Can anyone give us a degree? Excellent. Degree is 4. The maximum possible number of turns, as Taylor said. So it's max possible number of turns is the degree minus 1. If the degree is 4, this function cannot have more than 3 turns. What do I mean by turns? Max, min. This is what I mean. Yes, exactly. Turn. Turn. Turns. That's what I mean by turns. Max, min. So the degree is 4 indeed. What is the maximum possible number of turns then? 3. In this case, 3. The function does not have to turn 3 times. It cannot turn more than 3. So let's think about the x cubed. You remember x cubed, right? What is its degree?
3.
How many turns can it have? How many does it have?
0. Turns.
Look, this is x cubed. This is x cubed. Tell me how many turns it has.
It's like an S.
None. Exactly. It doesn't have to have. So it can have 2, but it doesn't have to have any. Okay? Good. So 3, that's okay. We're done with that. Now I would like to talk about end behavior. end behavior. This is what we call end behavior. What happens here? And what happens here? When x approaches infinity or negative infinity, we don't know where the function is going. Since the degree is, one more time,
4.
the degree tells us, which is 4, that will have the same identical behavior with x squared. If x squared has a positive leading coefficient and it's coming from positive infinity and going back to positive infinity, this function will follow the same rule. If the leading coefficient of this function is negative, it will behave like negative x squared, coming from negative infinity and going back to negative infinity. So what is the leading coefficient of this function? Which means it will behave like x squared, coming from
Positive infinity.
and going back to, excellent. So this is infinity, infinity, and this is the end behavior, done. Okay, now I would like to address number 2. So let's take a look at this function and find its x-intercepts. I still have time, done. Right. So how do I find the x-intercepts for this function? Very good, awesome. So I have x to the 4th minus 2x cubed plus x squared equals 0. Do not do anything before you answer the question. How many solutions will you find?
4.
Exactly 4. Even if they're all the same, which is not going to be the case. But even if they're all the same, I have to find 4 solutions because that is the degree, correct? Okay, so I will factor out x squared. I cannot divide by x squared. I will never do that. It's not possible. And I know how to factor this. How do I factor x squared minus 2x plus 1? This is not a binomial, it's a trinomial. It cannot be x plus 1 times x minus 1.
X minus 1 squared.
Very good, awesome. So now I expect 4 solutions. What are they?
No.
2 of them are? Exactly. 2 of them are 0. And 2 of them are? 1. Very good. How many times does the solution x equals 0 appear in this equation? Multiplicity 2. How many times does the solution x equals 1 appears as an x-intercept? Multiplicity 2. Is 2 plus 2 the degree? Perfect.
So the multiplicity is 0.
So we've solved these types of equations millions of times before. X times x minus 1 times x minus 1 equals 0. If this is 0, if this is 0, if this is 0, and this is 0, we find 4 solutions. 0, 0, 1, and 1.
I'm just confused on why we call it multiplicity. I don't like definitions.
That's the name. That's the name.
So the multiplicities will always will add up to equal the number.
To the degree. Correct. Yes. Is this okay? Everyone?
No. So is it 2 because there's 2?
I have 4 factors. I have to have degree is 4. I have to have 4 solutions. I have 4 factors. I have 2 factors x, so then the solution is 0. I have 2 factors x minus 1, and the solution is 1.
Okay, so the 2's go because there's 2 zeros and there's 2 ones.
I have to find 4 solutions. Yes, exactly. Yes. Is that okay? Good. So multiplicity 2 and multiplicity 2 in this case. Ladies? So multiplicity 2 in both situations. Why are multiplicities important? What's the point? Why? So what? So what, that solution x equals 0 and 1, in this case, both of them have multiplicity 2. Here is the answer.
Turns.
Exactly. That's the answer. Even multiplicity.
Because as soon as you start talking, that's what makes me want to conclusion.
So even multiplicity will do this. Or it will do this. So this is multiplicity 2. But multiplicity 4 of a solution does this. We see the difference? It still has one solution there. But the fact that the multiplicity is 4, it will take its time. It will take a longer time for it to touch and go away, drive away from the x-axis. Here, it's just a turn, a quick turn. Here, it's a much slower turn. Yes?
So it's the spaces in the turn, not the turn, it's how many turns it has.
There, exactly. There is only one turn. There is only one touch, one tangent. But it will take very long to get closer and closer and finally touch it. Instead of doing this, it does this.
Is that considered a constant?
A constant? There is only one touch. It's not horizontal.
Okay.
It's not horizontal. It takes longer to touch. It gets closer and get closer and then closer and then closer touch. The first one has close, close, close touch.
It's just a new way of thinking.
So every time the multiplicity is 4 or higher, like 6 or 8, it will be even slower. So let's see, since we are here, let's also talk about odd multiplicity. In other words, if x equals 0, I mean, I can stop talking. If you continue talking, it's fine. I mean, I can just talk over you. Thank you. So if the multiplicity were 1, the function would have just crossed straight. But so this is multiplicity 1. But if it's multiplicity 3, and we've seen this before, and I said to you, make sure that when you graph x cubed, do not graph it like this, because the multiplicity here is exactly 3. So all these are turns, but all these are crosses. And multiplicity 5, it takes even longer. So this is multiplicity 5. So remember when we graphed x cubed, I said do not graph it like this, but graph it like this, because there are 3 solutions at that point. Okay, so then we have 0, turn, and 1 and 0, turn. The function is not symmetric. That's the last thing. So the range will be determined after we graph the function. The max min has to be with the graphing calculator. The last item here is symmetry. And then we can graph. So this function that has a turn at 0 and a turn at 1 cannot be symmetric, but I have to write that, put that in writing, and say f of negative x does not equal f of x, and it does not equal negative f of x. Not symmetric. Okay, let's graph. I have all the information summarized in the table. I don't care for anything else but my table. Nothing else matters. And you can say, is this enough? Yes, that's enough. It really is enough. You don't have to, you can determine 10 more points if you want, anywhere you want. Negative 3, negative 4, negative 5, I mean negative 3, negative 2, negative 1, through 2, 3, 4. You can determine as many points as you want. Plug in the x that you want, but there is no need. There is no need. So I have to plot 0, 0. I have to plot 1, 0. And now let's try to understand what's happening here. So I expect the function to do this. Something whatever in the middle, but I expect it to do this. So it starts at positive infinity. It comes down to the origin where it turns. It has to turn again because it comes back down to 1, 0 and turns again to go to infinity. One more time, from positive infinity to the origin where it turns. But it has to come up to some number, some height, some maximum, because it comes back and turns again at 1, 0 going to infinity. So here it is. As a maximum, comes back, turns, and this is our function. Do I know how high this is? No. Can I? No. I have to use the graphing calculator for that. Okay. Let's put it in y equals clear if you have anything else. So we have x to the 4th, and then minus 2x cubed, and then plus x squared. I know now, since I graphed the function, I know that the action happens all around the negative 2 to positive 2, right? So I can adjust the viewing window the way I want. So I'm going to say negative 4, let's say, to positive 4 with a scale of 1, and negative 4 to positive 4 with a scale of 1. I'm sorry, I did something here. I meant 1, yes, thank you. So negative 4 to 4 with a scale of 1. So let's graph. Okay, so it's coming from a positive infinity. It turns at 0. We know that this is wrong. We don't trust this because we graph the function with it by hand. So now I have to zoom in order to see exactly what we just graphed. So I'm going to go and change the y maximum and the y minimum. And let's see if this does the job. If not, I'll adjust it again. It turns at 0. It has to go to a maximum. It has to come back at 1, 0 and goes to infinity. I can determine the maximum. It's between 0 and 1. So we go to second and calc, and the maximum is number 4. And it's between 0 and 1. I don't want to guess, just give me the maximum. It's 0.5, and the maximum is tiny maximum, 0.625. I'll put it in my table at 0.5 and 0.0625. And then I'll go back to my graph, and I'll say I know this now. It's 0.5, 0.0625. So this is a local max. Now from the graph, you can give me the range, and I'll put it in. Very good, indeed. 0 to infinity.